I thought we'd start this series of videos just doing a quick run through on what the screen looks like when you come into the scoring module. So this is shown on a wide graphic screen because I believe you need this much real estate to actually fit everything on. You could do it on a laptop screen, but the problem is that you keep getting windows flicking over the top of what you're doing and it becomes a bit distracting. So for the price of about 160 Australian dollars, you can buy this gaming monitor and it fits quite nicely. So up here we have the current options. Edit rondels, import scanned images, calibrate target rings, and we'll go through all those in later videos. But at the moment I'll just show you how this works. So here we have a window where you'll see the live video image from the plug-in camera. Now it only becomes active after you've actually, or in the process of, scoring a target. This window will show you the image that you capture when you hit the record button. The image that appears here is each individual rondel as it is scored and as it is reviewed. This is the provisional score that the system gives each rondel. This is the final score that is accepted when you hit this save button, and you can overwrite at any point in time the provisional score if it's obviously wrong or if the result of the plug suggests that the score should be either higher or lower. This area up here is where you enter the scores for each rondel. I've restricted the use of the keyboard because individuals continue to put in irrelevant and erroneous information, which then has to be sorted. Now this is for the WRABF targets, so they're the range of scores that you can get. Here is the plugging tolerance that is set, currently at 4 pixels, so if the system believes the edge of the hole is within 4 pixels from the scoring ring, it will call for a plug. This is the current plug size, again set on WRABF rules at 0.224. For WBSF that'd be 0.222, and that will automatically change as you select different types of targets. I can change that now if I wanted to go and run another target, and it moves by 5/10 at a time, but for the moment we'll leave it on 0.224. This is the message center. This gives the user some advice on what they should be doing if the user forgets where they are in the process. Up here we have a number of options. So we can pause the scoring after locating the rondels. We can pause scoring for immediate review as we go through each rondel on each target. And we'll do that to start off with, just to show you how it works. We can draw the outline of the bullet hole as well as what it perceives to be the plug on the target. I can restrict the plug options. So if I score a hole an 8 and suggest it could be a 9, the X in fact will be disabled, the 10 will be disabled, and the 7 down to the 0 will be disabled. So all you will be able to score it is a 9 or an 8 or whatever it could possibly be. You can turn that off. That gives you access to the full range of scoring, but it's designed to be there as a failsafe just so you don't make an inadvertent error. Auto print score label on save. Once you save the scores, it automatically sends the scores at this moment to a label printer. We could configure that to send it to a piece of A6 paper on a laser printer or an inkjet printer if that's what the user wanted. This option then says once you process the scanned images, you can actually delete the scanned image. Now, unlike TrueScore, which uses JPEGs, I use a TIFF file format. Now, a JPEG is probably about 2 megs. A TIFF is 45 megs. The problem with JPEG is that it's a lossy format, and when it expands back up, the algorithms, if you haven't got the latest version in the scanner or your software, what it will do is it will leave black artifacts. And black artefacts, if they bunch together, will start to represent a bullet hole. So all of a sudden the software starts finding bullet holes or bigger bullet holes where there are no bullet holes. So for that reason, it'll keep a copy of the target in a JPEG format for reference, but it will in fact, if you tick that box, delete the 45 megabyte file so that you can save on disk space. This is a turn diagnostics on and off. I won't bother showing that. That just gives me some information as I was developing the program. I'll turn it on. You can see that there's a whole lot of information comes up there that I can watch as the program runs through, looking for error tracing and things like that. But when the user gets it, that'll be password protected, because if the user does have a problem down the track, I'll give them the password to turn that off and they can give me some information and I might be able to help track down their error. But by default, those diagnostics will not appear. These two sliders here represent the sizes of bullet holes. So the minimum value is 150. So anything under 150, and it's square pixels, it doesn't recognise as a bullet hole. Anything above 1500, it recognises as the possibility of 2 bullet holes. So if somebody puts 2 shots in close proximity and the hole it cuts is rather large, the system will flag it to say there could be 2 shots in this hole, you need to check. This box here will be all the target's scanned images that we import, and as we go through the process you will see this list here build where the targets are renamed based on the shooter number, the match and the target number. Now these are WRABF matches, so this current program accommodates the 5 different matches shot in WRABF: light and heavy air, international sporter, light and heavy rimfire varmint. Over here we'll actually have an image of the target. Here we'll have the clipped out barcode image that it scans to read all this information, and then it just writes the shooter number, the match name and the target number. There's a clock here to tell you what time it is and what day it is, just in case you forget. Now across the bottom here we have 25 rondelles, we have 25 scores, and as we go through you will see those scores increment and the target score increase through here. There's room to put in here a target penalty for things like a crossfire, which it will subtract off the target score to give you the final score. Now once all the issues have been resolved with each individual rondelle, the save button will actually become visible and you can save the scores. So let's just run through a very simple one now that doesn't take much work. So we'll bring it in. We'll say, here it goes. And it takes a little while for the first one because it's got to load the scanner driver. So that's scanned and pre-processed, cut all the rondelles out. So now we'll go through and score it. Now we hit the pause for immediate review before, so we get 1, 2. We'll come back to that one because it needs plugging. 3, 4. Now that's fairly slow. So if you uncheck that, which I would suggest most people do, and hit the button, it'll scoot through and just do the whole 25. Now you have the option to come back and review. As the message says, please review the highlighted rondelles, number 2. Now notice you can't store that yet because one rondelle still needs review and they're not all green. So let's go to rondelle 2. When we click on that, it'll bring it back up. And the message says there's a plug required. It says I'm scoring it a 10, but it could be a 9. So you would turn the camera on, and in fact that's the very rondelle that we're looking at, and you can move this camera around to position it wherever you want, and when you're happy with it, and that's a dead set 10, you hit the record button and it records it, and there's the name of the image. It's the shooter number, the match, the target number, the rondelle number and plug. So later on when I'm editing, I can actually, if there's a protest, I could actually bring that back so that the protest committee can have a look at the image on which the score was called. Now you'll notice down here a little microscope comes up, and that means that I have an image of that plug number 2. Now I still haven't resolved the score yet, but we said it's a 10, so we go up here and we go 10 plugged. Now the message comes up and says I can save scores now because they've all been resolved. They're all green. And we'll see a little plug come up here, and in fact it's a spark plug because I don't have an icon for a bullet hole plug yet. I haven't made one of them, but it'll look a little better. So we'll just go through and have a look at some of these so that you can get some idea on. See, they're obvious X's, there's no doubt about that. That one's a 10 by a mile. There's a 9. Now that's a 9. Is that a 9? Oh, well, let's just have a look. We'll put the camera in, and sure as eggs, that is a 9. So we could record that one, and up comes the plug. We won't bother scoring it because the score was correct, so we don't need to rescore it. So 14, yeah, we can see that's a 9. 17, no worries for an X. 20's an X. 23, 25 is a 10. Now I have this up here, auto score print label on save. Now, there's his score, 247.13. And I'll hit the save button and you'll hear the printer print out, hopefully, the score label. There it goes. Okay, so that's the first video. We'll leave it at that. The next one I'll show you will go through with a bit more of a complicated target where it can't find the barcode and the shooter's number and things like that. And it's got missing rondelles for whatever reason and whatever. So next time, have a look at this. Let me know what you think. And maybe in a few days I'll do another video. So that's it, gents. See you next time.